Alright, so let's take a look at number 9. So number 9 is combining a couple different things. It's an inequality, right? So you see the greater than or equal to there. And it's also an absolute value, so you see the absolute value bars. So it's that same situation where we're talking about when we measure distance, distance is always a positive number, and what we don't know is that are we counting from the negative side or the positive side. But again, it doesn't matter which side you're counting from because the distance is always going to be positive. Well, one of the things that you have to do first here is that you see there's kind of some extra numbers floating around. There's this -5, and then there's this ×2. So the first thing that we need to do there is we need to isolate the absolute value. And what that means is that the absolute value needs to be by himself on the left side of the inequality, and then everything else over there to the right. So the first thing I do would be to add 5, right? Because you always get rid of the constants first. The numbers that are right up next to it, we get rid of those last. So if, and I just would, kind of copy this down, right? So -5 plus 5, 11 plus 5, which would give us 16. And then I'm going to divide both sides by 2. And then so I get the absolute value of 2x minus 4 greater than or equal to 8. So that's what we mean about isolating the absolute value. The absolute value is now by itself on the left side of the inequality. Now that it is, then I can go ahead and solve it. So I'm going to go ahead and solve for 2x minus 4, the absolute value of 2x minus 4, greater than or equal to 8. So as we said, a number could be coming from two different sides of the number line. So we said that you really have two different cases. You have the positive case where the numbers are just going to stay the same, or you have the negative case, which is where we're going to switch. So with the positive case, like I said, we're just going to copy it just like we see it. So we'd have 2x minus 4 greater than or equal to 8. And that stays a positive 8. And then the other thing that we have is that for this side, we've got 2x minus 4. I'm going to separate this. So we've got 2x minus 4. And then, but we're switching, so we have to switch this to a negative 8. But then because it's an inequality, we have to switch both. So we have to switch the sign and the number, right? So let's make sure. So for this one, we're going to switch the sign and the symbol. Sign meaning positive to negative. That's what we're doing right there. And then the symbol meaning the greater than or equal to turning into a less than or equal to. And then we can solve it from there. So let's add 4. And actually, you can kind of do both of them at the same time if you want. Because from here, it's going to be the same. You're going to be doing the same things. 2x less than or equal to -4. Right? Different signs subtract. 8 minus 4 is 4. Keep the sign of the bigger. There's more negatives, so that would be a -4. 8 plus 4 would be 12. And then we're going to divide both sides by 2. So you get x less than or equal to -2. Remember, different signs, same signs positive, different signs negative when you multiply or divide. And then x greater than or equal to 6. So here's our two possibilities here. X less than or equal to -2, and then x greater than or equal to +6. So we want to graph that on the number line. Let me move my number line here a little bit. So -2. So I would start at -2, -1, -2. And we're saying less than, so less than means all the numbers smaller. So it gets smaller if I head to the left here. So that would be all the numbers less than -2. For +6, 1, 2, 3, 4, 5, 6, it says greater than. So greater than means all the numbers bigger than 6. So the numbers get bigger as you go to the right. So there's really kind of two parts to your answer there. We want to come up with the solution, and then we want to come up with the graph of the inequality. All right, so go ahead and pause now and try 9.2 and 9.3. All right, so let's check your answers for 9.2. So we got x less than or equal to negative 2 or x greater than or equal to 3. And then for 9.3, she got x less than or equal to negative 5 or x greater than or equal to 10. All right, and that concludes number 9.